Okay, so the first thing that we'll go over is the measurement notes. In your book, I believe this corresponds to the reading for chapter 2 that I had you read for today. So did you cover measurement issues, nominal, ordinal, interval in your research design courses? Okay, good. So that should be reviewed. Basically, what we're going to do is just review these really fast, and then you'll be done for the evening, so you can go and check SPSS and then do the homework. So the first slide says concepts to variables. The very elementary component of testing hypotheses is you're looking for the relationship between concepts or variables. For example, the variable of income and years of education. You can test statistically whether or not they are related. And those would be considered variables. We use variables as a way to measure concepts. So for example, if we had a concept, and I'll just use this really quickly. If you had a concept called economic development, so you have economic development. You have to define that, come up with some conceptual definition of what economic development is. Off the top of my head, before class, I just said it's the extent to which an economy is growing. I don't know if I'm writing big enough, but so you have a concept of economic development. I've defined it as the extent to which an economy is growing. So we've got concept, operational definition. Now we need to say if we want to measure economic development to run statistical tests, you have to come up with a variable. You may disagree with what variables are used. One common one that you might have is GDP, or gross domestic product of a nation, or a city, or a state, whatever unit of analysis that is. So you start with your concept of economic development, you define it with an operational definition, the extent to which an economy is growing, and then how do we measure that with a variable. And I've here suggested GDP. Somebody may say a better variable is new business startups. That's possible, number of new businesses starting out. It's probably captured in GDP though.
You have multiple variables?
Yes, you can. Yeah. Once we get to regression, you could put in both of these. GDP, new business startups. You could put in a measure of wages. So per capita income or something like that. That would be the variable and the data that you would collect. So you can easily collect from Bureau of Labor Statistics, maybe Census Bureau, World Bank, I think, collects the data on GDP. So you can get numeric values for GDP of a country. You can also probably get, a little bit harder, but the number of new business startups, and you can definitely get wages, data on wages. Your book also refers to these variables, or going from concept to variable. They may use the word indicator or indicators. So the indicator of economic development could be same thing as a variable. GDP, wages, new business startups. Questions? Okay, another concept, just to drive home the point, you could have a concept of political stability of a nation. So political stability. The definition I came up with was the extent to which a nation is absent of authoritarianism. So political stability, I've defined it as the extent to which a nation is absent of authoritarianism. In their government, there's no dictator, there's democratic elections. One way to go about creating an indicator or variable, variable or an indicator, that I pulled off the top of my head is years since democracy. So how many years has the nation been democratic, held democratic elections? So if a nation was authoritarian until 1990, then instituted democratic elections, and they've been democratic ever since, then that would be 27 years. And that'd be a data point of the variable years since being a democracy. If they had just recently became a democracy, they've been authoritarian since 2015, and they became democratic in 2015, then the value for that variable would be 2, if we're looking at this year. So these are just ways of going from concepts to actual variables that you can observe and get hard data on. And all of these you can get to varying degrees of difficulty. Questions about concepts and measurement? It's really easy to get variables that are counts, like years, or what do we do before years? GDP counts, just dollar figures, or years since democratization. That's a number. It gets a little bit more difficult when the variables aren't hard counts. So, for example, preferences. Whether you agree, strongly disagree, or neutral. It's a little bit harder to observe that because it's not a hard number, but we can survey individuals and we can use those data points in analysis. The important thing to do, though, with your categories of your variables, categories have to be mutually exclusive. You cannot be 2 of the same thing. So if you're taking a survey and somebody asks you your approval of President Trump, you have to give an answer, and you can't give 2. You can't say, I agree and strongly agree. Okay? You got to give an answer. You can't be both. Just like gender, you can't be both male and female. They're mutually exclusive categories. Sometimes this means within reason, I guess. Yeah, within. I guess you'd have to rephrase it. What was your gender upon birth, or then what is your identified gender? And that would probably solve that. Sometimes, especially with approval ratings, like strongly approve, neutral, disapprove, or strongly disapprove. You also want to put a do not know, because you don't want to necessarily force somebody to answer if they really don't know, or if they prefer not to answer. You can also put refuse to answer. And there's all kinds of classes on surveys and survey design where if you don't offer those, how does that skew your results because you're forcing somebody to answer or not? But make sure that the categories are exhaustive. They include everything that you can possibly think of. That usually goes into that other category. For example, on political party preferences, are you Democrat or Republican, Independent, or other? Because you don't know every political party or every political leaning of somebody in your survey area, so you can just lump them in with other. And so some examples that are are good in terms of variables and how they're categorized, or the categories comprising the variables. Party preference, I just mentioned Democrat, Republican, Green, other. You also probably want to put a don't know, refuse to answer, or no response on there. Student grades can be a variable with the categories A, B, C, D, and F. Again, it's exhaustive. All grades are represented there, A, B, C, D, F, and they're mutually exclusive. If you got an A, you certainly didn't get an F. You can't have an A and an F. So one person fits into one category. Variables can have components that are simply yes or no, like recidivism. Did somebody commit a crime after getting out of prison? Yes or no. That works. Charitable donations as a variable, pretty easy to calculate that or observe that. It's in dollar figures. So here on the example slide are a list of variable names and then the categories of the variables. Okay? Or if your book uses the term for variables, indicators and the categories of the indicators. I think you've covered most of that in previous courses. So the next slide, make sure this is recording, is dependent versus independent variables. Did you cover this in research design? Okay. This is a very important concept with statistics. You need to know what your dependent variable is and what your independent variable is, because you need to know which order to put them into your computer software, because the computer software is going to spit out anything. You put whatever you want in there, it's going to spit something out. But if you don't know what the independent and dependent variable is, you're not going to truly understand the relationship between two concepts or two variables. So the dependent variable is the one that gets affected. It's the one that's changing. It's the one responding to some sort of stimuli. It's dependent, hence dependent variable, dependent upon X, Y, and Z. Those X, Y, and Z's are your independent variables. They do the affecting. The dependent variable gets affected. The X, Y, and Z's, the independent variables, do the affecting. So if we say that income is a function of years of education and gender and years experience, income is the dependent variable. Income is being affected by gender, years experience, years education. So education, experience, gender are doing the affecting. They're the independent variables. The dependent variable income depends upon those three. Next slide shows an example from a statement which can be, it's an empirical statement, meaning data can be collected and can be tested. Okay. So it says people are interested in teen sexuality and teen pregnancies. Suppose somebody wants to study abstinence-only education and argues that the presence of abstinence-only education reduces teen pregnancies. So somebody may hypothesize that. Abstinence-only education's in sex ed where they don't talk about contraceptives, it's just don't have sex. Somebody hypothesizes that abstinence-only education reduces teen pregnancies. What is the independent variable in this statement?
Education.
Yeah, the education program or the abstinence-only education. It's doing the affecting and or the manipulating, and it's manipulating or affecting the dependent variable, which is teen pregnancies. So teen pregnancies, the dependent variable is a function of the education program, or teen pregnancies depends upon the abstinence-only education program. In your homework, there'll be several statements where you need to identify dependent variable and independent variables. Questions about that before we move on? Okay. The other component that's very important is understanding what are nominal, ordinal, and interval level variables. When we get to statistical testing, it is very important to know, especially for your dependent variable, what level of measurement it's measured at, nominal, ordinal, or interval, because that level of measurement dictates what statistical test you can run. And again, you can put a dependent variable into the computer, and the computer will spit out numbers for any test that you want, even if it's the wrong test. So say you run a t-test instead of a chi-square. Suppose you're supposed to run a chi-square, which we'll study, I think, in week 4. Say you're supposed to do a chi-square, but you run a t-test. The computer's going to spit out a number, but it's going to be wrong. And so your conclusions will be wrong. Support or rejecting your hypothesis will probably be wrong. And so you got to know what test to run, and that depends upon levels of measurement. So, and I put in bold, it is the most important element to know in terms of research design and then picking which test to run. Nominal level variables are typically pretty easy to identify. Okay? There also can be called categorical variables. So gender, for example, is a variable with categories. You're either male or female. It's a nominal variable. You fit into one box within reason, male, female. Political party that you affiliate with is a nominal variable. It is categorical. You fit into one of the categories: Democrat, Republican, Independent, other. Did you vote or not? That variable, voted, yes, no. And you either yes you did, you fit in the yes box, or you fit in the no box. That is a nominal variable. Okay? You cannot order the categories of the variable. So for gender, the categories are male, female. You can't order them from high to low, male or female. There's no measurable difference or distance between the categories within reason, male, female. No, you can't, greater than, less than, you can't put a numerical value to rank order them at all. Political party, if the categories are Republican, Democrat, Independent, other, there's no rank ordering of anything there. There's no higher, lower, greater than, less than. And the difference between a Republican and Democrat, we cannot quantify. You just simply fit in the box or not. Voted, yes or no, or any type of variable where its categories are yes or no. Really, you can't say one's greater than the other. And there's no measurable distance between them. You just fit into a box. And so typical variables that you'll see in social sciences that are nominal are gender, race, political party. Okay, questions about nominal variables, the concept? All right, next slide introduces Excel. Excel is a very good tool for data entry. It's an incredibly horrible tool for doing statistical analysis. It's real easy to enter data, and we'll talk about principles of data entry throughout the course. And as you look, I put the slides 2 to a page, you see that there's a screenshot of Excel. You see in the screenshot, basically this is a 5-person survey: Jane, Bob, John, Billy, Susie. And in this survey, they've been asked their political party, their age, their approval of say the president, their gender, and their income. So in Excel, the variable names will appear across the very first row if you're doing good principles of data entry. When you download from the Census Bureau, it's not always that case. You have to clean it a little bit. But generally speaking, you want to keep it very, very simple. Keep it basic. And this is a very basic setup here. Variable names are in the first row, and each column represents a specific variable. So party is a variable, age is a variable, approval, gender, and income. Variables vary. Okay? So there's ways to vary on political party. You're Democrat or Republican in this case. The variation in age, age varies from young to old, and there are the numbers there. Same with income. Gender varies, female or male. Approval varies. There's different values for approval. So it's set up in that manner, and it's also set up so that, for example, we were surveying individuals. Jane is a Democrat who is 18 years old, strongly approves of the president, female gender, and makes $53,432 a year. Go down to Billy. We surveyed him. He's person number 4, fourth person. Republican, he's 35. He disapproves of the president as a male and makes $32,798. This is a basic setup that you'll see most survey data is set up as. Keep it very simple. What you'll see is that we've initially entered the nominal variables of party, because you're either Democrat, Republican, independent, or other, and gender, you're either female or male. Those are the two nominal variables in this mock survey, party and gender. And we've entered D for Democrat, R for Republican, F for female, M for male. Perfectly fine to enter data like that, but when you start running analyses in the computer, SPSS or any statistical software will not be able to understand what F and M means. It cannot read letters. It cannot run any kind of analysis on letters. It only likes numbers when you study the relationship between two variables. So what we have to do is we have to provide numbers for the categories of Democrat, Republican, and numbers for the categories of female and male. Remember I said nominal variables are not numeric, they're categorical. You fit in a box, there's no greater than or less than. The numbers that we assign to each category they're just placeholders. They take the place of letters so that the computer can operate. So for example, we put here, we want to code 0 for Democrats and 1 for Republicans. So on the next slide, you'll see where we've changed, where everybody was a D, they should now be a 0 under party, and where everybody was an R for Republican, they're now a 1. So if you flip back and forth between the two Excel screenshots, you'll see that. Even though we're using numbers as placeholders, those numbers do not have a greater than or less than. The 1 and the 0 representing Republican as a 1 and 0 as a Democrat does not mean Republicans are more than Democrats on any kind of measure. Same thing with gender. It looks like we coded females as 0 and males as 1. Males are not greater than or less than. There's no distance between those 1s and 0s. Those 1s and 0s are simply placeholders so that the computer can run analysis. So there's still no measurable distance between male and female and the other categories on party affiliation, and there's no distance between them. It's just ways that we have to use as placeholders for the computer to operate. It does not matter which one's 1, 0. You could do males 53, females 108. It's simply a placeholder. It doesn't make much sense to have those numbers like that. It makes most sense to do 0, 1 or 1, 2. It's easier for entry. And that's what you'll see with most of these. So again, the numbers are just simply placeholders. When you get to ordinal level, so the concept of an ordinal level, ordinal level measures or variables are usually your Likert scales, hence the word, and so focus on the word scale. Approval ratings, happiness, happy, neutral, unhappy. Approve, neutral, disapprove. Strongly approve, neutral, disapprove, strongly disapprove. Ordinal level variables have a rank order. You can rank order happiness, you can rank order the values of approval rating from strongly disapprove all the way to approve. The order makes sense. However, there's still no measurable distance between the categories. All that we know between going from approve to strongly approve is that there's more approval, but we don't know by how much that is. Nor do we know the distance and whether that distance is the same from approve to strongly approve as the distance from neutral to approve. Question?
So when it comes to like the approval and you're categorizing it as ordinal,
Uh-huh.
so under approval you're one or the other. So where would approve, strongly approve, I mean, you're only one.
Right. So when you survey somebody, the question will be, how do you approve of the president's job performance? And I'll say, the options are strongly approve, approve, neither.
So what would be the line where that wouldn't fall into a nominal or ordinal?
Why it's not nominal?
Yeah, because you're only one of those.
You're only one of those, and you're fitting into a box, right? But you can rank order those preferences. That if somebody is a strongly approve, and the other person that you surveyed is an approve, you know the person that said strongly approve has more approval than the individual who said approve. So you simply can file them from low to high, high to low. Does that make sense? Okay. Yeah.
Sir,
Yeah.
so the neutral
Mhm.
figure. So you go to president approval or disapproval rating. So
Yeah.
let's say you use a 1 as approved. The neutral would have to be 2, or neither approve or disapprove, and the disapprove would have to be 3. So pretty much what I'm asking is the neutral one have to be in the middle. If that makes sense.
No, but it's best. It's best for your sanity to do that. So here I'll show you. So the Likert scale, we've got agreement or approval. Let's see. So it looks like, well, we've got approval or agree. I switched the wording. So if you look at the slide that says levels of measurement ordinal, and it's got the coding 43210. So you've got 4 is strongly agree or strongly approve. 3 is agree. 2 is neutral. Did you have a question too before I?
Let's get to it. One thing I was going to say, which comes later, it seems like with these, with the organ ones, central tendency kind of lend itself with using these type of studies.
Yeah. So yeah, we're gonna get to that, like reporting the average. Yeah. So you can only report the median for these, and I'll show you once it's. I think the next set of slides, the next paper. 1. Disagree. 0. Okay, so it's set up as, in your notes, 4 represents strongly agree, 3 represents agree, 2 is neutral, 1 is disagree, 0 is strongly disagree. This is perfectly fine because it's in order from low to high. And so neutral is technically still in the middle, right? Yeah, so you can go from 0 to 4. You could reverse it, which to me just makes it confusing because I like to see that the larger number means more agreement. And we know that 4 has more agreement than 3, which has more agreement than 2, which has more agreement than 1, and so on. You could reverse it and do 0, 1, 2, 3, 4, and code it that way. It's just now that the larger numbers mean more disagreement. As long as it follows a logical order, you're fine.
Would you ever want to have, like, let's say neutral, could neutral ever be 0?
Yep.
That's not.
And then like -1 be
Yep.
disagree and -2 be strongly disagree?
Like that? Yeah.
So it's just your method.
Yeah, it's your method. You just got to know, sometimes when you introduce the negatives, when you run analysis, you might get a negative coefficient, which we'll talk about weeks from now. But as long as, yeah, it's your method, whatever you want, as long as the order makes sense. Okay? You see that the larger numbers are more agreement, and the numerically smaller numbers, because the numbers are smaller, is less agreement. you could not do something like this. 3, 2, 4, 0, 1. There's no order. It makes no sense. So as long as you can rank order low to high, high to low, that's how you do it. And that's what we've done in the Excel example, is that wherever you see a SA, there should be a 4. Wherever you see an A for agree, there should be a 3. And so when you flip over to the next slide, you'll see that. Like its definition as an ordinal variable, those numbers represent rank order, so they have a little bit more meaning. They're a little bit more than just simply placeholders. We know that based upon our coding that a 4 means more agreement or approval than a 3. So it's a little bit more specific. The last, are there any questions about ordinal before we? Okay. The last type of variable is probably the easiest. It's interval. Interval tends to just simply be counts. Interval level variables are quantifiable. The numbers mean something, so they can be rank ordered. And the distance between each of the values is meaningful, and it's the same across every value for that variable. So for example, age, okay, it's a count. We know we can rank age because in numbers, 1 is less age than 55. We also know that the difference between ages 1 and 2 and 54 and 55 are exactly the same. It's 1. So the distances between the categories are exactly the same. They're quantifiable, measurable, they're exactly the same. Same thing with, make sure this is still recording. Yeah. Same thing with money. Quantifiable, observable. We know that $1,001 is $1 more than $1,000. The difference is $1, and that's the same between $1 and $2 to $1 million and $1 million and $1. These tend to be the best measures if you can get them. Obviously, you cannot have an interval level measure for gender. You have to use nominal. But where possible, use interval. They're the most powerful measures you can have. So like miles, number of employees, GDP, number of write-ups, number of children, all interval level measures. And when you look at them in Excel, you just enter them directly, like income. You enter the exact income. Okay, so that sums up the levels of measurement. We don't have a lot more left, so we won't take a break. Are there questions about measurement before we go on to central tendency? And we'll only, on central tendency, please be sure to bring these set of notes for next week because we're not going to get to dispersion today. You'll have for your reading next week, you'll be reading about the standard deviation and then z-scores. The first part of that, standard deviation, is dispersion on these notes. Please print off the z-score notes also because we'll cover that. So we're going to stop after the 2, 4, 6, 7th slide on central tendency. All right. Central tendency is just a fancy phrase for when we get a measure of central tendency. We just want a measure that tells us what the typical value of a variable is. So if you saw the Excel spreadsheet on the notes and we were looking at, say, the income variable, there were 5 observations. We want to know what's kind of the central value, the average, or the median, and we'll get into the difference in a second. But what is the typical value or the representative value of that variable in that survey? Same way with the gender variable. Well, what would be the typical value? What's the central or essential tendency of that variable? And the same with the Likert scale of the agreement or the approval. What's kind of the central or the typical value of that variable in the data set? The measure of central tendency that you can report depends upon how your variable is measured. So the level of measurement of your variable, nominal, ordinal, interval, dictates what measure of central tendency you can report, whether or not you can report the mean, median, and or the mode. The mean is the average. I'll use those terms interchangeably, average or the mean. Median and mode don't have different definitions. So we'll start out with nominal variables. Remember, nominal variables are the categorical variables like political party or gender. The only measure of central tendency that you can report is the mode, or the most often repeated value of that variable. So if you look back at the data set that we had in terms of gender, and look at the one where gender is represented by numbers, where we've coded females as 0, males as 1. For that nominal variable, you can only report the mode, or the most often repeated value. So the mode is what? 1 or males. So males, represented by the value of 1, is the modal value, or the measure of central tendency for gender in this case is males. There are 3 1s and 2 zeros. So that's the 1s represent males. There's 3 males, 2 females. So the most often repeated value is 1 or males. For party, political party was 0 for Democrats, 1 for Republicans. Political party is nominal, and you can only report the mode, which is 1s, which are Republicans. If we had added a 6th person and they were a Democrat, and you had 3 Democrats, 3 Republicans, you'd have to report both as modes. You can have multiple modes. The mode's not a very good measure, and it's very rarely reported in any types of statistics. Right, question? Yeah.
The most often repeated what?
Value of the variable. Yeah. Okay, ordinal level variables, still on that the slide on the central tendency notes. You can report the median or the mode. The median is the more powerful measure and the one that you probably should report. And you might wonder, well, how do you, when you have a Likert scale of values, how do you go about reporting a median? So I'm going to make something up off the top of my head like we see in Excel. Individual, 1, 2, 3, 4, 5. And let's do approval. So if you're looking at Excel and you contacted 5 individuals and their approval rating is individual 1 is disapprove, 2 is neutral, 3 is disapprove, 4 is strongly approve, 5 is approve. The way that you would calculate the median is the central value or the middle value where 50% of the cases are below it, 50% of the cases are above it. It is the true center. It's not necessarily going to be case 3. I mean, that appears to be the center, but the important rule of finding the median is you have to place your values in order. Okay, so we'll go from strongly disagree up to strongly agree. So we have a disagree, a neutral, an agree, and a strongly agree. Once you've placed all these in order, all the values for all your cases, from low to high, find the middle case. Well, the middle, where 50% are to the left and 50% are to the right. That's easy to eyeball. That's neutral. Yeah.
If you have an even number of individuals selected, is it the center two?
Yeah.
Okay.
It's the center, it's the average of the two, which, say if you added 6, and we're going to put strongly disagree, just to make it a little bit difficult. So if we added strongly disagree here, it's problematic with ordinal. When you get actual real numbers in here, well, then it's easier. The central case, well, is between these two. Yeah, so you would just simply report that the median response or an approval is somewhere between disapprove and neutral. Now, if these were hard numbers like number of kids, like 0, 1, 2, 3, 4, something like that. When you get to numbers like incomes or counts or number of kids, then those are the two middle. That's 2 plus, then the average of those two is 1.5. 2 plus 1 divided by 2 is 1.5. Pretty easy to see when you have a small number of observations. But when you get to a data set that has 100,000 observations, it becomes a little bit more difficult. The general formula to find where the median is, the middle case, is if you use the equation n plus 1 over 2, n being the total number of observations you have. So you take n, the total number of observations you have, add 1, and then divide by 2. That equation will give you the location of the median once you've ordered from low to high. Always the first step when finding the median is to order from low to high. So, in the case where we had 5 observations on the approval scale, n is 5 plus 1 is 6 divided by 2 is 3. So location number 3 is where the median is. Here's location 1, here's location 2, or excuse me, sorry, get rid of that strongly disagree and go back to the original. 1, 2, 3. Well, we eyeball. When it's an even number, say the n is 10, we have 10 observations in our survey. 10 plus 1 over 2. And take 10 plus 1 is 11 over 2, which is 5.5. And what does that mean? That means you need to go to cases 5 and 6. Okay? And it's the average of those two cases. So don't let the 0.5 scare you. It's just that the median value is located at position 5.5 or between 5 and 6. And then you would calculate the average of the two values at positions 5 and 6. Okay, we'll do an example here with both. Let me come up with some numbers. Okay. You can use the median with ordinal. You can also use it, and it's often better to use it than the average for interval level measures. So I'm going to do an interval level measure here and calculate the median. Let's see. Okay. So if you have a series of numbers, 31762, The first step is always to reorder the numbers from low to high. So we're going to order that 1, 2, 3, 6, 7. N is 5. It's our total number of observations is 5. So the location of the median is 5 plus 1 over 2, which is 3. So case 1, case 2, case 3, there's your median. And you can eyeball that. It's small. Questions? Let's put an even number of series and more numbers. This time I'm going to put it in order for ease of. Okay. Okay. Here's the series. 1, 2, 3, 4, 5, 6, 7, 8 observations. 0, 1, 1, 1, 4, 7, 8, 10. So all put into the numerical order. 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 observations. The equation defining the location of the median n plus 1 over 2 becomes 8 plus 1 over 2, which is 9 over 2, which is 4.5. Yes. So that means the median value is located between observations 4 and 5. And 4.5 tells you to look at between observations 4 and 5, or take the average of 4 and 5. So 1, 2, 3, 4. Here's case number 4, and here's case number 5. So we have the median, and you see that 50% of the cases are to the left, 50% of the cases are to the right. The median is the average of these two. So 4 plus 1 is 5 divided by 2. The median is 2.5. Even though 2.5 is not an actual number in the series, it's a value that is the median that represents the central value. 50% of the cases are above, 50% of the cases are below. All right, questions about the median? The mean is one that you're probably familiar with. It's the average. When you get to an interval level measure like ages of individuals in society or incomes of a city, you can report the mean, median, or the mode. Don't report the mode. That's mode you're never really going to report at all. You can report both the mean and the median, okay, depending upon how that variable is distributed. The median may be better than the mean. Okay. But first, how to calculate the mean or the average. Okay, here's what looks like fancy math. It's not. Okay, your book will represent the mean as either a Greek letter mu, or oftentimes it'll be x with a bar over it. Okay. But for the time being, we'll use mu. And that equation says looking thing is a sigma. Says to add. It's an addition operator. So it's saying add x sub I. X sub I just means each individual value of x in your data set of the variable that you're measuring. So take each x and sum. So add up all of the x's, all of the values for your variable, and then divide by the total number of observations, or the total number of values. So if we had Excel individual, and we were looking at the number of kids they had, so let's do individual 1, 2, 3, 4, and 5. Individual 1 has 4, individual 2 is 2, individual 3 is 2, individual 4 has 1, individual 5 has, let's take it at 10.
You slow down.
you could calculate the average. The average, the equation just says sum up all of the x values, so sum up all of your observations for the variable that you're interested in, so number of kids, so sum up all these. So 4 plus 2 plus 2 plus 1 plus 10. It's 19. Ah, I should have come with a better number. 19. So that's your sum of all your individual x's is 19. Now, for the average mu, you take that sum and divide it by total number of observations you have. So we have 19 is the sum divided by, we've got 5 observations that we took. 3.8 is 19.5, which equals 3.8. That's the mean or the average. 3.8. As a measure of central tendency, the mean might be a good representation or it might not. Basically what you need to do is report in any type of your statistics that deal with an interval level, report a mean and a median, because what you will see is the median number of kids, 0, oh no, we had 1, 2, oh no, I'm blind here, 1, 2, 2, 3, 4, 10. Yeah. I'm sorry?
5 plus 1 over 2.
Yeah, yeah. So
5 is 3.
so it'd be case number, so here's the data set, right? 1, 2, 2, 4, and 10. So n is 5 plus 1, it's case number 3. So the median is 2. Does that make sense? We have an average of 3.8, we have a median of 2. They're both measures of central tendency or typical value. I would argue one measure is a little bit better and better measures the typical value of number of kids. Which one is probably a better measure for this variable number of kids? I hear both the mean or the median.
The median. Because ain't no point.
Well, median because 10's an outlier. 10's an
Yes.
outlier and throws everything else off.
So those that said median are correct. And this is why you should really always report both the mean and the median so that readers can understand if there's anything called, as it should be on the next slide, skewness, okay, as I put caution with the mean. The mean or the average is always susceptible to an outlier or extreme values at the high end or extreme values at the low end. In this case, we've got, 1 kid, 2 kid, 2 kid, 4 kid, and then 10 kids. That 10 kids is an outlier within this series. The outliers will always pull the average or the mean towards it. And that's why the average is 3.8 and the median is 2. Because the outlier, if it exists, will pull the average or the mean to it. Hence, why the average is 3.8 and it's greater than the median. Questions? Mean, yes, the mean / the average is always pulled towards the outlier. Anytime where the mean and the median are not the same, there's a level of skewness. Anytime where the mean and the median are the same, that's pretty good. Very rarely will they ever be. That's why you should report both. Where you see this, where it's more problematic, it's not too problematic in our example of number of kids. 2 and 3.8 is not terribly huge. The median's a little bit better of a measure. But if you look at Census Bureau, income, figures will always usually be from the census median household income, median House price too. Yeah.
Dr. Shuttleworth, in your notes where it said, to report both because the statistic best represents the central tendency, like what would be an example of, like what would a central tendency be for you to either have 2 or 3.8 kids? Like,
It's not always, when you get a 3.8, it's a mathematical artifact. You obviously can't have 0.8 of a kid, but it's more precise to say that people have 3.8 kids. And it says, well, if that's the average in the United States, well, people aren't having, it's somewhere between 3 and 4 the best measure, with the leaning towards more likely that people are having 4 kids. It's a much more, it's not in reality you're going to get 3.8, it's just a more precise measure. I wouldn't, no, leave as is, yeah. Same with incomes, same with house prices, just leave as is.
So let the user of the data
Just, yeah, and you say it's 3.8, which means it's close to 4. And then, because if say 2 years ago the average number of kids was 3.6 and now 2 years later it's 3.8, if you had reported 4 for both series, you're going to say there's no increase, but a 0.2 increase still suggests that the birth rate's going up. So be as precise as you can.
so I have another.
Yeah.
And maybe I'm overthinking this. I just want to make sure I understand. But when, so in the note where it says the reader can judge with statistics.
Yeah.
I mean, since those numbers are so different.
I would say you've got, when you look at the relationship between the median and the mean, if there's a disparity, a large disparity, and you have to look at what context you're looking at. If it was the difference between the mean and the median of your yearly income was a difference of $1.8, they're pretty much the same. There's not much discrepancy. When you get down to something small like number of kids and 1.8 difference between the mean and the median, okay, then it's starting to get pretty important.
Okay, so you would probably have to do like some more research with it in that kind of.
Yeah, I mean, basically just kind of put it in with context and see if the difference between the mean and the median is huge or not, given what you're measuring. Again, with income, it's not a lot, but if it's say life expectancy in years, 1.8 might mean something, especially for medical studies or number of kids. Where you usually see this is in incomes. If you were to do, say, we'll say I'm pulling a number out of my head. If median household income is something like $48,000 a year in the United States, I'm not sure what the median household income is. But what I can guarantee you is that if you looked at the mean household income in the U.S., it's going to be greater than $48,000 because there are a few outliers out there, like the Bill Gateses and your CEOs that are making billions of dollars. Most people are making living wages, but the average or the mean is pulled towards Bill Gates. He brings up those numbers. So that's why it's the case where the median is a better representation, is if there's any type of skewness. In this case, with incomes and with the number of kids, we saw high outliers. So Bill Gates brings the average up. That person with 10 kids brought the average up. That means that there is a positive skew. Right? So it's being skewed positively towards high numbers. If the number of kids were something, say people had 10, 8, 7, 9, 0. Say your society's got people having 10, 8, 7, and 9 kids, and then somebody having 0. Your median, let me reorder it, 0, 7, 8, 9, 10. So you got a very reproductive society, except for one individual. Median here, the middle case, is 8 kids. If you were to calculate the average, it's going to be less than 8 because of this outlier. Oh, you already got it? 6.8. So median equals 8, mean equals 6.8. So the mean or the average is pulled to the left. In this case, it's called a negative skew because the values are being skewed towards the smaller numbers. So any time where the, get a new sheet here. And we're almost done. If you have a mean greater than the median, that's called a positive skew. And if you have a mean that's less than the median, that's called a negative skew. And a positive skew means your mean's being pulled to higher numbers. Negative skew means your mean is being pulled leftward to smaller numbers. You can see this in a distribution of, you see the little like curves on the skewness slide. What this represents, and you probably have to look pretty closely, it's called a frequency distribution. You'll see C1 in your homework. Okay? But basically the y-axis on the graph is the density or the frequency of observations. Okay? And the observations are on the x-axis. So it could be number of kids, it could be income as the variable, it could be number of write-ups, it could be GPA of students in a university. It could be, probably the easiest thing to think about is exam scores on the x-axis from 0 to 100. Like, let's look at it that way. So if it's exam scores on the x-axis and the y-axis just says the frequency or how often they occur. In the first panel, okay, you see a symmetrical curve, okay, a distribution of test scores that are symmetrical. They didn't put in a mean or median actual value. But if you look closely, it says MD and X bar, and it shows it at the height of the curve or at the hump, at the largest value. Okay. That's saying that the median and the average are the exact same, or the median and the mean are the exact same. Okay. That means you have a perfectly symmetrical normal distribution. We'll talk more about normal distribution next week. But it's a perfect bell curve. You could fold that curve in on itself, and it's a mirror image. It's perfect. At the median, we know that 50% of the cases are to the right, 50% of the cases are to the left. And that so happens, since it's perfectly symmetrical, the mean and the median are the same. So 50% of the cases are above the mean, which is the median, and 50% are below the mean, which is, in this case, the median. Perfectly symmetrical. Mean and median happen to be the same. The next one, this is where some people get confused, but the middle panel shows a negative skew. The mean is skewed towards where the tail extends out, where the tail gets long. And in this case, in that middle panel, you see that the tail is longer, it extends out to the low values. It's not where the hump is bigger, it's where that tail is. So there's a lot of low values in that middle panel, and generally the population is at a high value. So this would be a case, for example, on an exam where most people are doing pretty well. Most people have pretty good scores, but there's some really, really bad scores that are outliers off to the left. And what happens is the mean or the average is pulled towards the tail that extends out. It's pulled towards their low values. And you'll see there, if you may have to squint, they've listed the median as MD, and it is to the right of the mean, which is represented by X bars. So the mean is less than the median, which we know is a negative skew, and that's when you've got some outliers at the low levels. It's where that tail extends out. This would be the case with the last example of kids, where we had people having a lot of kids, except for that outlier of 0. That tail would be towards that 0. The last panel on the right shows a positive skew, like incomes in the U.S. or house prices in the U.S. Most of the values are within the big hump, but there's some outliers to the right. Very expensive houses, multi-million dollar houses, or billionaires in incomes way off to the right. That tail out to the right are your Bill Gateses, your really rich people. And what happens, it pulls that mean or the average towards that tail, and you see if you squint, it says X bar, and X bar is to the right of the median, represented by MD. So the mean is greater than the mean is being pulled towards that tail. And that is a case of positive skew. And there's the last slide that we'll go over today just summarizes what we just did. Questions as we move forward? Let me double check on the homework. Okay, so the homework, let me pull it up. Actually, I don't think I have it here.